Hello everyone, welcome to another one of my Leetcode videos. In this one we'll do today's daily challenge, Leetcode 472, concatenated words. So basically we're given an array of strings words without duplicates, and we need to return all of the words in this array which are concatenated words, which means they're formed by concatenating two or more other words in the input, right? So for example, this one has a dog, cats, and dog. All of these are other words in the array, right? So we need to return all of the words here which are just composite of some other words. So this is a very interesting problem. Like, the first approach that comes to mind is, okay, we'll just create a set of all the words, right? And then for each word we'll try to loop through. If there's a substring that is part of that set, we'll like cut it there and then we'll keep going. But if we do that, there could be a substring that's part, but then the rest of the string fails, and then it turns out that you actually need to cut it, like let's say here, and then it works out, right? So even if we try to do that kind of approach, processing each string that is actually a concatenated string will take too long, because it will be like a 2 to the n kind of algorithm, right? So uh, for each string you need to partition it in all the possible ways depending on what exists in our set of words. So it could be a very expensive algorithm. And so one way to typically optimize these type of questions, where you have a known list of strings and you want to search if something is in there, is to use a trie data structure. And let's sketch out how the trie will look like to solve this problem. So since trie is not a very common data structure, I'll just first just briefly go over what a trie is, right? So let's say you had a list of words, let's say cat, dog, and catfish, right? And we want to insert this in a trie. So we'll have our root TrieNode here, right? Which when we insert cat, we'll say, okay, C, A, T, right? And we'll mark this as an ending word, right? So we'll mark this letter as that we've ended a word over here at the T node. Then when we insert dog, we'll say D, O, G, and we'll mark the G as the end of the word. Now when we insert catfish, which is already in the trie, we'll just use, since we already have C attached to this node, we'll traverse the same path, C, A, T, and then append here F, I, S, H, and mark this as the end of the word, right? So this is basically what a trie data structure looks like. Obviously, each of these are also trie nodes, so the same rules apply. So basically, the way we'll use the trie to solve this problem is, we'll know that if it's, for example, catfish, right? So let's say if we had fish in this array, we'll have F, I, S, H. When we insert catfish, right, we know that when we insert cat, it's going to pass through a node which we've already marked as ending, right? So when we insert catfish, if cat is already inserted, we'll see that catfish passes through a node that's marked as ended. And if this is the case, we'll put catfish in an array for subsequent processing, right? So that we can then say, okay, we need to process catfish to see if the rest of the string also exists in the trie, right? But then for this to work, we have to insert words in order of their length. So we have to insert the smaller word first, right? And the smallest word can't be a concatenated word because the length's the smallest. So if we insert the words in the order of their length, then we know that, okay, when we insert the concatenated word, it's going to pass through by one of these E's, right? And then we'll save this entire concatenated word for future processing. We'll say, okay, this word at index I, let's say it's whatever the index I is, let's say this is index 2 in the original array, and starting from maybe index 0, 1, 2, so starting maybe from index 2, right, we found the end word, and we put this in a queue to process further, right? When we're done inserting all the words, we go back to this list that we've accumulated of to process in the future, and we look them up in the trie. So then if we see fish, okay, we'll see FISH is in the trie, right? And if we reach the end of this word, then we'll add this catfish word at index I to our final answer, right? And if, let's say if there was also an ending word here, right, then that means we could cut it off at fi as well as one option. Then what we'll do at that point is in the same queue, we'll add, okay, the same word at index I, we can also process it at index 2, 3, 4, right? So we can also process it from index 4. And so then it will check if sh is in the trie. And obviously, once we find that we reach the end of the word and it's in the trie, we'll save it into a set so that we won't reprocess this. So let's say if I2, this iteration successfully reaches to the end of the word here, when we try to process I4, because we would have added that to our queue, because if we saw that this is an ending word, then when we process that word, we check it's already in the set, and so we just skip it because we already know that I is a concatenated word, so we don't have to process it again. So this might be a bit overwhelming, but let's get into the code and then we'll see how things work. So as we mentioned earlier, let's first sort our words array by length, because that will help us insert them in an order that we want. So I've gone ahead and sorted our words array by comparing the lengths of the words. Now let's create our TrieNode, because this will actually hold our trie data structure. So here's our TrieNode. We have a map of character to TrieNode as our map, which will initialize to an empty map, and we have an isEnd, which will initialize to false. So here we'll hold our TrieNode, which will be our root node, and we'll initialize it to a new TrieNode. Next, we'll create our queue of things to revisit, right? So I'll just make it a 2D integer array, where this is going to be word index and letter index that we need to revisit. So this is initialized as a new queue. And now what we'll do is we'll just go through each of our words. So here's a loop that goes through all the words. Let's just go ahead and insert the words in the trie. So to insert the word in the trie, we need to start with, our tracker node, which will start at the root, right? So that we insert each letter starting from this node. And then what we'll do is we'll loop through all of the characters in the word. So here's a loop looping through each letter in the current word that we're processing. And now let's just go ahead and grab the character. So this will be our character, words at I, caret j. And now we'll try to insert this character in this tracker node, right? So if tracker already contains the current character, or sorry, if it does not contain the current character, then what we'll do is we'll add a new node for that character, right? And now that we've done this, what we'll advance our tracker to say tracker.get c. And all of these actually should be tracker.map. So let me just update that real quick. So I've updated that. We want to operate on the map of the tracker. So now that we have that, if at the end, when we reach the end of the word, we'll mark this tracker.isEnd equal to true, right? So now what we want to do is if we find another word along the way, right? So basically tracker keeps track of our way. So we say if tracker.isEnd, that means we found another word that ends on this way, then we need to add this word to our list of things to revisit, right? And we're guaranteed that this can't be the ending of the word itself, because this doesn't have any duplicate words, and we only mark the current word to end at the end of this loop. So if this end is true, it must be another word that's ending somewhere else. So in this case, what we'll do is we'll add to our list of things to revisit the index of the word, which will be I, and the index of the letter to start checking again later when we revisit it to j+1. So now with that, that adds everything to our try. And so now let's just go through this queue. We'll say while not this queue is empty, we'll first poll from the queue to get the word and letter index. Then we'll grab our word. So I've grabbed 3 variables, the word index, the letter index, and the word from the words array. And now we need to look for this word in the try, right? So let's keep track of our node. TrieNode, again, tracker equals to root, the same algorithm as above. Now this time we'll start looking from li, right? Because that's where this is asking us to resume. And we say j less than word dot length j++, and let's grab our current character. Now we've grabbed our character. So if this character is not in tracker.map, that means it's not in our try, we'll just break, right? Because we know that now this word is not going to be a possible compound word because it has a this subsequent part of it is not in the try. Otherwise, we'll just continue. We'll say tracker equals to tracker.map.getC, right? And if we see that tracker.isEnd, right? That means if we reached the end of another word, right? Then what we need to do is, okay, if this end is also the end of the current word, right? So if j is equal to word.length -1, that means it's also the end of the current word, then that means we found an answer, right? So let's keep track of a set of answers for deduplicating. So if we find this, then we have answers.add I, right? Otherwise, if this is not the case, then that means we need to look for, that means we've reached the end of possibly another word, right? So in the example we had earlier, like if we had cat and then fi and then sh, maybe fish exists, but fi also exists, right? So in this case, what we want to do, if we reach the end that's not yet the end of the word, we'll add it to the queue for further processing, just in case, in case fish doesn't exist and sh does exist, right? So we need to add it to the queue for, again, running through the same algorithm where it looks for the remainder in this try starting from the start. So we'll add to our queue, again, the index of the current word, and the letter index will be j+1 because we want to start looking from the next letter. And obviously here, we might reach the end, right, and find the answer. Then that means the next time when we pick it out, we don't want to process that anymore because we already know that that word is already an answer, right? So over here, what we'll say is if answers.contains wi already, if we've already know that this is an answer, then we'll just continue, right? We'll skip this word. So that, I think, should do it. Now at the end, we want to convert this answers, which holds the word indexes that we've already processed, to a list of strings, right? So let's just create our list of strings real quick. I've created our list of strings. Now let's just loop through our answers, and in our result we'll add words at wi, and at the end we'll return our result. So let's run this and see how this does. I missed the new keyword. This should be wi, and line 42. This should be wi as well because we want to add the word index to it. All right, accepted. Let's submit. Perfect. Thank you so much for watching. I'll see you in the next video. We could have probably done better here by not sorting it, right? Because you could still technically, add everything to the try and then do this with every word basically. And then just know that if you reach the end of the same word, you somehow skip it. So maybe that's possible, but I think it'll make it a bit more complicated. And this is a hard problem. The approach should be to get a good, decent working solution first and then optimize. So yeah, try to optimize it. Let me know in the comments how it goes. And yeah, like and subscribe if you like this content. Thank you.